Hey guys, my phone overheated, so I had to throw it in my lunchbox for a second. But I'll come back to our little training lesson there. This piece is installed. I got that done when my phone was cooling down. Let me come back to this little tutorial here though. Basically, there's 3 challenges to that piece. There's challenge number 1, which is measuring it. Challenge number 2 is marking it. And then challenge number 3 is cutting it. So I've already been over some measuring challenges, some of the inherent flaws with framing squares, tape measures, speed squares, anything like that. So that's your first inaccuracy, is going to be on your measuring tools. Your second inaccuracy is actually going to be on the mark itself. So I kind of alluded to that earlier with the Sharpie mark, right? Yes, there is a mark on 20 inches, but it's such a inaccurate mark that if I try and cut that, I'm going to be plus or minus a 16th. You can go down the list from there, and you can use a thinner Sharpie, then you can use a pencil, and if you really want to get fancy, you can use a box cutter, right? So I'm going to take my box cutter and make a little tick mark right there. I'm not sure if you can see that. Theoretically, even a box cutter, if you put that under a microscope, is going to look like the Grand Canyon. It's still inaccurate, theoretically. Practically speaking, a razor blade is about as precise as you need to get for any of this kind of work. So practically it would be accurate enough, but the practical problem with that is that I got to carry around a tape measure and a box cutter for everything that I need to cut. And that's just not practical. It doesn't make sense. Theoretically, it's inaccurate, but practically speaking, it's 12 extra steps that I don't want to do. There is a way to get a more accurate mark than even a razor blade, and it's also faster, and that's what they call a crow's foot. Crow's foot is actually the measurement is actually the absence of a mark. It's the point in between those 2 lines. It's more accurate than a razor blade because if you zoom in on that under a microscope, those 2 lines will just get infinitely more precise at the corner. It's also a lot faster to carry around a pencil and just do this versus trying to get my box cutter out. Potentially the material that I'm marking, I don't want to deface, so I don't want to be cutting composite material with a box cutter because it's going to look like trash when I install it. So pencil mark with a V, they call it a crow's foot. More accurate way of measuring, and I guess that gets me into the cutting part of things. I'm sure you guys have heard the expression take the line, leave the line, or split the line. Let me show you what that means. So let's say, I don't know what measurement this is, we'll just say it's 2 feet or whatever, and that's the cut I'm trying to make. I know that the center of my crow's foot is the true measurement, right? So that kind of compensates for some of the inaccuracy on my tape measure. But when I go to mark it, I'm going to reintroduce some more of the same inaccuracy that we just got rid of, right? Because I'm going to put my speed square on that, and now I just got rid of that perfect little crow's foot, and I replaced it with a big fat pencil mark, right? Here's where the take the line, split the line, leave the line comes in. I can visually see where the corner of my crow's foot is. So if my pencil mark is right on it, and that's exactly the measurement I need, then I'm gonna leave the line. I'm gonna leave the pencil mark on this material and take everything else past it. If my pencil line is off one way or the other, I might split it, and I'm gonna put an X on the line to know that I'm gonna split that line. The kerf of a blade is about 1/8 of an inch. So this is what my blade is actually going to cut, right? There's my pencil mark, but that's the material that my blade is actually going to remove. So depending on where my mark is on that crow's foot, I'm going to leave the line, split the line, or take the line. I'm going to take up to this pencil mark. So if there's my pencil mark and I want to take the line, my blade kerf is right there. I'm going to take it, right? But not exceed it, right? If there's my line but I want to leave it, my blade kerf is right there. If that's my line and I want to split it, the kerf of my blade is right there. Does that make sense? So this crow's foot is a more accurate tick mark than any of these other options that we tried over here. It's going to be a more accurate mark. The other problem with just doing a single mark like that is that if you're not perfectly straight up and down, like if your mark is right there, you're going to get two different measurements on two different points of that line, if that makes sense. That crow's mark is always going to be perfect on your, I'll zoom in on that one. So I'm 12 times magnified right there, and you can see the corner of that crow's mark is actually, can't even find my razor blade. You get the idea. It's just a more accurate mark. So I'm compensating for the inaccuracy on my tape measure with a more accurate pencil mark. And then next to my crow's foot, I'm going to put an X that tells me which side of that corner I'm actually cutting on. Am I taking it, leaving it, or splitting it? And when I go over to my saw, I'm lining up my blade on whatever point of the pencil mark that I figured out. So I think that pretty much covers the measuring and marking. Well, I guess, so now that here, let me come back to this actually. Here's the practical, here's where we actually start applying this. The piece that I am trying to cut is a picture frame, is the outside of a picture frame with two mitered edges, right? That's the piece that I actually need to cut. If I try and just cut both miters to length at the exact same time, hopefully it works, but if my miters aren't perfect, I don't have any material left over to adjust those miters. I'm just going to create a bigger gap on each corner. So there's a temptation to just leave that piece super long, right? And then try and cut it down and adjust that angle. That's one way to do it. The problem with doing that though is that if that piece is too long, I'm not even going to be able to drop it in place to where I can compare that angle. So the key is to leave it just a tiny bit longer than what you actually need, and to get your angles as close as possible on the first cut, right? And then drop it in, test fit it, and then if I need to change an angle, I've got a 1/16 of material to play with, which is plenty if you're only adjusting it 0.1 degrees, you know. So I did my math with a bevel gauge and a speed square, and I came up with 45.6 is the angle that I need, right? 45.5 is actually what I originally came up with. So if that's that angle, it's hard to hold that. If that's that angle and I mark that, then when I go up to my saw, I'm going to put an X on it that tells me to leave the line. And that pencil mark gives me enough wiggle room. So I cut it at 45.5 originally, but I cut it a 1/16 long because I left the line, right? So it's accurate enough it's close enough in length to where I can actually drop it in and see if it's a good fit. And if it's not, then I can adjust it, but it's not off by so much that I'm starting out at 45 degrees and I've got to make 6 different cuts to get the actual angle. I started off at 45.5 and made one cut to adjust it to 45.6, if that makes sense. I think that kind of wraps up the marking and measuring section of this. This piece is installed, so in my video on that note, but it's acceptable to me. Yeah, I don't hate it. I got a nice consistent gap up against the deck board right beside it. Anyways, I hope that helped you guys. This deck is about 54 feet long, and I'm about an 1/8 inch out of square, which your house is probably not that precise, to be honest. In terms of framing, that's about as good as it gets. But when you start doing finish work, none of my miters are 45 degrees. They're less than 45, they're a little over 45, whatever the case may be. And that's where you would notice it. So you're never going to notice that the framing is an 1/8 inch out of square. But you would notice finish work that is cut for a square deck and installed on a deck that is not square. You would notice the finish side of things. So when people say, wow, it's really tedious, you got to sit there and figure out those angles, you really don't. You have the tools for it. The only challenge is just using your eyeball to actually see what the angle is. But it's the same process. Like if my saw didn't have a positive stop on 0 degrees, like it actually locks into that notch. If it didn't have that, then I would still have to do the same thing and turn my saw until my eye thinks it's on 0 degrees. That's exactly what you're doing with a speed square when you're calculating the angle of these miters. So the amount of work involved in getting a clean miter is the exact same amount of work as doing a sloppy miter. The only difference is just how you're actually reading your measuring tools. So that's it for today. I hope that helped you guys. I'm gonna keep plugging away. I started this section last week just so I could put material and tools up there, but I gotta get this section installed now, and then hopefully by the end of the week start putting in some spiral stairs down there. That'll be an interesting process. If I'm actually able to do it, I'll make some videos on that as well. Anyways, God bless you guys. Have a good day. Bye.